Hello everyone. Some people asked me how I calculate the 95 PPU and the P factor and R factor. So in this video, I'm going to show you how you calculate these. If you recall in video, well, I think it was number 2, where I explained the SPE program, I showed this in slide that says the output uncertainty is quantified as the 95% prediction uncertainty calculated at the 2.5% and 97.5% level. And then I showed that you start with your parameter range, then you do a number of Latin hypercube samples, which is the number of simulations you want to do. And then you give that to the model, and model gives you discharge. And then you use that discharge at every observation point to calculate the frequency distribution. And from that frequency distribution, you calculate the cumulative distribution, and your 95 PPU is the distance between the lower and the upper limit as 2.5% and 97.5%. Now I'm going to go through the steps and show you how exactly you can calculate this. Assume that you have 15 measurements of flow, such as this column, the row here. And then the first thing we want to do is to calculate the frequency distribution. So the first step is I sort these from smaller to the larger. And then I decide on the number of intervals that I want to have in the frequency distribution. This is up to you. You can choose 10, 15, 20, depending on the range of and the number of your data points. Usually around 10 would be okay. And then to calculate your interval size, you simply subtract the largest number from the smallest number, and then you divide it by the number of intervals. So in this case is 0.671 is the size of our interval. In the next step, you calculate what your intervals are. So we have 10 intervals. Here are 10 intervals, and from 1.1 to 8.7, that's how they are divided. And then from that interval, you calculate your frequency. That means the number of data points that fall into each one of these intervals. So from 1 is 1 by itself. The first one is itself, one number here. From 1.1 to 1.8, we have 4 numbers, flows here, that fall into this interval. In the next interval, from 1.8 to 2.6, you have another 4 flow data that fall into this interval. And then you have 2 that fall into this interval, and then you have 1 in the next one, and then you have some 0, 1 here, and then 2 zeros, and then in the last one you have 1, the number here. Now, let me go to Excel. I did this once, but I'm going to go through it step by step here and show you how you do it. So let me column, this is my flow. And I'm just going to copy this and paste it here so I can sort it. And then I sort my data. I go to data, you sort it. I jumped up, let me just bring it down because we need that space. Then I decide on the number of my intervals number of intervals. We said we're going to use 10 intervals, and then the size of interval is going to be equal to the largest minus the smallest divided by number of intervals, which is 10. So that's the size of my interval. And then I come back here. So the first one is itself, 1.07. And then the next one would be this one plus the interval. So the next one is going to be equal to this one plus my size of interval, and then I'm going to fix this C21 $, and then I just copy this all the way down until I reach my last number, which is this one, so I don't need this one. So this is the 10 intervals, and those are the divisions. Let me just, to make it easier, format this so that we have 2 decimal points. It's easier to see. And now the next is here I showed you that we calculated by hand manually the frequency distribution. Here I'm going to use Excel to give me the frequency distribution. So I go to data and data analysis and histogram. Histogram is the same name for frequency distribution. Okay, and then it wants the range. So the range of my input is from here to here. And then it wants the bin range. Bin range are my intervals. That's the bin range. And then it wants the output range. That's where to put the data. So I choose this here and OK. And it gives me the frequency distribution. To adjust everything, let me just move these. Let me just move these a little bit down. All right, so that they're all at the same level. Now, so these numbers, as you see, 144211, 144211 is the same as what we had done manually. Now, that's my frequency distribution. If I sum this, of course, it's going to be equal to 15, right? The number of my data points. Now, next, I want to calculate the percentage of data that falls into each category. And this is equal to 100 times the number of data points divided by the total number of data points, which is 15. And I copy this down. So these are the percentages. Again, to make things simple, let me just limit this to be even 1 decimal point. It would be easier to follow. So these are my percentages. Let's say percentages. Just put a percent here. And then the next thing that I want to do is to find the cumulative percentages. So the first one is just the first one, 6.7. And then the next one would be just add this to that, right? So this is equal to the previous plus the next one. And then if I just go down here, of course, the last one is going to be 100, right? That's the 100%, that's the distribution. So this is my cumulative distribution. And this was my frequency distribution. So I could plot this maybe. Insert, I have to do it like this. And then we get rid of this, and then I will change the chart type to a column, and there is my frequency distribution. That's the same thing that I had plotted in the PowerPoint here, right there. So that's the frequency distribution, and now this is my cumulative distribution. All right, so now let me put my data together here. I have my flow interval, and I have my cumulative distribution, so I can plot them. Here, pay special as values. Let me change this again to only 2 digits. Okay, so now I can add some zeros just to make our graphs go from 0. And then if I plot these against each other, insert, scatter. So I have here my cumulative distribution. So here, let's make it nice a bit. Get rid of that and just this, so they are sort of the same. We could make little changes here. Cumulative distribution always goes to 100. And here I could make this go with the unit of 1. Alright. So what I need to do now, so that's my cumulative distribution. I need to get 2.5%, as we talked before, and 97.5%. So I need to know what is the flow at 2% and what is the flow at 97.5%, and that makes my 95 PPU. For that, let me go to my PowerPoint. And here is the same graph as my cumulative distribution from 0 to 100 here, and that's my flow interval. And now I need to calculate 2.5% and 97.5% to see what my flow is at these levels. So, right? And then here is my 95 PPU. So now the question is that how do I calculate what that is? So for that, let me show you this graph. I'm using triangle proportionality theorem. This is my data, that's my flow interval, and that's my cumulative distribution again. Now, 2.5%, as you see, it falls in this interval from 0 to 6.7, and 97.5% falls into this interval here. So I can just plot, I can say at 1.1 I have 6.7 on the cumulative distribution, so I can draw these orange lines. And then at what I would like to get is 2.5%, so this is my x. So using the proportionality law, I know that rise divided by run here, which is the slope of my cumulative curve, rise divided by run, which is here 6.7 minus 0 divided by 1.1 minus 0. So that's that distance and that's that distance. That should equal, I call that the ratio or the slope. So that should equal this rise over this run. So for this triangle, I have rise over run is equal to rise over run. So here I have 2.5 minus 0 divided by x minus 0, right? Now from here I can calculate x is equal to this. You can do the math, and I need to now calculate what it is at 97.5. For that, at 100 I have 8.7, right? 100 is 8.7. The next 93.3 is 7.9. So 93.3 is 7.9. And I want 97.5, and which is x. So if you look at this triangle here, this triangle, I can apply the same law here, that triangle and that smaller triangle. So here I have 100 minus 93.3 divided by 8.7, which would be that distance, minus 7.9 would give me this distance here, or that distance there. That's my ratio. That's equal to 97.5 minus 93.3, which is that distance here, or this one, divided by this x minus 7.9. And x is 7.9 plus this. If you do the math, that's what you get. So I can take these equations to my Excel sheet. So I have to calculate the ratio. As you were not watching, I brought this formula here and highlighted the two intervals that we are interested in. So the ratio, according to my formula, is equal to rise, which would be this minus that value, divided by run, which would be that minus this value. And then I can simply copy this down here. And I can calculate my 95 PPU according to the formula here. So this is equal to 0, which would be that 0 here, plus 2.5 minus this value here, divided by the ratio, and similarly this is equal to 7.92, which is this value, plus the value I'm looking for, 97.5, minus this value, divided by the ratio. Alright, so this is my lower 95 PPU and the upper 95 PPU. So the distance from here to here would be my 95 PPU for this data point. Now, we have to do the same thing for every data point, right? And when you do that, then you will get, you can calculate P factor and R factor. So let me show you. I have done that before and I'm going to show you, but first let me go here just to make a point here. Now, if you have one measured value, which is certain, right, 2.5, one value, and then we have my 95 PPU, which is a range of number, and then if this measured point falls inside the 95 PPU, then our P factor gets a point, a positive point, right? If my measured point falls outside the 95 PPU, then my P factor gets a 0, gets no point. That's very clear. But when it comes to the time that our measurement is also uncertain. So our measurement has an uncertainty band and our simulation has an uncertainty band. So how do we do that? Now, in this case, my measurement could have any value inside this interval, right? Any value. So if any value of my measurement falls inside the 95 PPU of my simulation, in the upper 95 PPU or in the lower 95 PPU, if it's inside, there is an overlap, or when it's entirely within my simulation, or when it's entirely outside, bigger than my 95 PPU of simulation, that's also possible, then my P factor gets a point. But if it is completely outside of simulation, with all of its uncertainty, then my P factor gets 0 point. And the formula, Excel formula for that is what I have here. And then R factor is simply the average of upper 95 PPU and lower 95 PPU divided by standard deviation of measured data. Now let me go to Excel sheet and then we can see the calculation here. So here is my observation. So I have 25 observations, for example, and I calculate for every point the lower and upper 95 ppU, as I've shown before. Then I can calculate, we assume a 10%, in SWAT-CUP we assume a 10% uncertainty about the measured data. So that what that means is that my measured data is not 1.4, but it's a number between 1.4 minus 10% and 1.4 plus 10%. So this would be the range of error of my measurement. And that's the range of error of my simulation. So I applied that formula that I said. Exactly the pictures that I showed you is all of those conditions. And then at the end, I sum everything. And as you can see, 5 of the data points get score of 1. That means they are inside, bracketed by the simulation. And to calculate the p-factor, I divide 5 by the number of measurement, which is 25. So it's 5 divided by 25. So my p-factor in this case is 20% or 0.2. Now my r-factor is simply upper 95 ppU minus lower 95 ppU, and then for all the measurements, and then at the end you average all those, and then you calculate the standard deviation of my measured data, and the ratio between the average and the standard deviation would be my r-factor. Should be 0.14, right? So I have a mistake here. So it would be 0.14. Standard deviation divided by that, okay, 0.14 is my r-factor. So that's how we always calculate p-factor and r-factor and 95 ppU. So I hope that this was useful, as many of you have been asking for that. So I thank you for watching, and please remember to subscribe to our channel. And also, if you need that Excel file after you subscribed, please write me and I will send you the Excel file. Thank you.